Okay, here are the solutions to the quiz review extra practice problems. First question says explain why this left-sided integral is not equivalent to this integral on the right side. On the left side, this is one that would require substitution, so you would let u be 5 minus x squared. And then when you take that derivative, you'd end up with negative 2x dx, which you only have x here, and I forgot my dx. There should be a dx there. I only have x dx, so there's this extra factor of negative 2, so I'd have to replace that x dx with a negative 1/2. This would need a negative 1/2 over here, and it doesn't, so that's why they are not equivalent. All right, number 2, remember integration from left to right of an area confined by the x-axis and some curve on the top will be the integral from 2 to 8 of whatever that function that defines the top is, which in this case is x minus 4 squared plus 5, and that would all be with respect to x. And I didn't ask you to actually evaluate that, you just had to write the integral. All right, next question is an indefinite integral, but one that requires substitution because what I have underneath the square root itself also has a derivative. So I would let u be the base, which is 2x minus 1. Then its derivative will be 2 dx. All I have left is a 1 dx, so 1/2 du will equal my dx. So substitution just allows me to rewrite my original problem in a much simpler form. So it is now is 1 over square root of u, which again I still can't integrate a quotient, so I'm going to write that as u to the negative 1/2. Then dx will be replaced with 1/2 du. Now I have something I can integrate. I'm going to go ahead and do that. 1/2 times, I take my power, add 1, which will give me u to the 1/2. Instead of dividing by 1/2, it'll end up being times 2, and then I have plus c. Final step is to simplify and undo your substitution. This will give me 1. I'm going to put 2x minus 1 back in. Instead to the 1/2, I'm going to write it as a square root, and then remember my plus c. All right, number 4. I have a couple of options here. I could square this out and then distribute the x squared. In other words, I could turn this into a polynomial because this isn't so bad, or I could use substitution because I see that if I let my base be x cubed minus 8, I do get that derivative of that within this problem. So I'm going to use substitution. So there's my u. Its derivative will be 3x squared dx. I have that extra factor of 3, so 1/3 du will give me x squared dx. So now this will get rewritten as 1/3 the integral of u squared du. So now I integrate, which will be 1/3 times u cubed over 3 plus c. 1/3 times another third is 1/9. Undo my substitution. And remember, I can check all these answers. I could take the derivative of my answer, and it better take me back up to the top. Let's see. The check, I'll use a different color. So here's my check for that problem. One ninth times 3 x cubed minus 8 will now be to the second power. Now I need to multiply by the derivative of the inside, which will be 3x squared. And you'll see when you simplify, 3 times 1/9 will be 1/3, then 1/3 of 3 will be 1, and I'm left with x squared times x cubed minus 8 to the second power, which is what we started with. Okay, number 5. I'm going to need substitution. I could cube this out and multiply, but it's a lot more work than using the substitution in this case. So there's my u. Remember, generally it's the base of the power. I'm going to take the derivative of that. And I have an x dx, but this 2 is extra, so 1/2 du will equal x dx. So my original problem becomes 1/2 the integration of u cubed du. So 1/2 times u to the 4th over 4 plus c, which will be 1/8 x squared plus 1 to the 4th plus c. All right, number 6, I'm going to let u be this part under the radical, because remember that is a power of 1/2. So the derivative of that will be 3x squared dx. Now this one is a little bit different. I have a 2 here up in the original problem, but a 3 down here. Remember, I need to make these equivalent so that I can replace that 2x squared dx with something du. Well, I need to make them equivalent, so what I need to do is just multiply to get a common factor. So I'm going to multiply this, or what I'm going to do is actually multiply by, multiply by 2/3. So I'm going to take this and multiply by 2/3 on both sides. And what that does is this gives me here 2/3 du equals 2/3 times 3 will give me 2x squared dx. Now I have a match here. So I can rewrite my original problem as 2/3 the integration of my u to the 1/2 du. 2/3 times u, when I add 1 I'm going to get 3/2, and it'll be times 2/3 again, plus c. So the answer will be 4/9 x cubed plus 1 to the 3/2 plus c. All right, number 7, I'm going to let u equal 2x. I'm sorry, sine 2x. Then du will equal 2 cosine 2x dx. Because the derivative is, I take the derivative of sine, which is cosine 2x, but then derivative of 2x is 2. So I'll have 1/2 du equals cosine 2x dx. So now my original problem becomes 1/2 integration of u du. So I'll end up with 1/2 times u squared over 2 plus c, which will be 1/4. Put my sine 2x back in, plus c. All right, number 8, I'll let u equal 8x. Du equals 8 dx. 1/8 du equals dx. So now I rewrite that original one as 1/8 integration cosine u, and then the dx is getting replaced with that 1/8 du. So it's 1/8. Integration of cosine u is sine u plus c. Take the u out, put the 8x back in. And we're done. See how the derivative of this would be 1/8 cosine 8x times 8. The 8 and the 1/8 would make 1. I'm left with just cosine 8x. All right, last one. I'm going to let u equal, remember pi is just a coefficient, it's a number. So then du will equal pi dx. I got a direct substitution here, so it's integration of sine u du, which is cosine u plus c. My u was pi x, so it's cosine pi x plus c.